Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today is Sunday and I am here with the solution of mock test 4. I hope that everyone has completed their mock test. By far, if you have not yet completed the mock test or if you are thinking how I can get the question paper for the mock test, first of all you have to subscribe to our channel, then you have to subscribe to our WhatsApp group. The question paper every morning Sunday 10 AM is shared on our WhatsApp group. So, you have to download the question paper. From there you have to solve the question paper on your own, and now you can check your answers. If you have not yet downloaded the question paper, go to our WhatsApp channel, link is given in the description below. Download the question paper, solve it quickly, then come back, open this video and check all the answers if your answers are correct or not. Also mention in the comment below how much you scored in this test. Okay, don't cheat, only mention the answers that you have successfully completed on your own. Okay, now let's look into the problems one by one. So the first problem, a very long straight wire carries a current I at the instant when the charge plus Q is at point P has velocity V as shown in the force. The force on the charge is along xy, along oy, along ox, opposite to oy, opposite to ox. Okay, so they have asked you to find the direction of the force. So first of all, let us try to find out what is the magnetic field. So this is a charge. I told you multiple times that how can you find the direction of magnetic field. So this is the current. So magnetic field, in this case you have to first align your fingers, your thumb in the direction of the current, then wherever your fingers will point, that will be given your direction of magnetic field. So magnetic field in this case is into the page, that is in the negative z direction, right? Now we know that so magnetic field in this case you can write it like this. So this is the magnetic field, this is actually into the paper. Now we know that the force is given by Q V cross B, right? So the force is Q V cross B. So V cross B, so if you start with V, go towards B, and the thumb will give you the direction of the force. So force is along OY. So the correct answer in this case is OY, along OY. So correct answer is option A. Simple question. Only thing that you need to be sure of is find the direction of force. For that, first of all you have to find the direction of vector B, then you have to use the knowledge of cross product, and then you can find the direction of force. Simple question, okay, very simple question and conceptual question as well. Now let's look into the question 2. A particle of mass m, charge q and kinetic energy k enters a transverse, very important, transverse uniform magnetic field B. After 3 seconds the kinetic energy of the particle will be. Now so suppose we have a particle moving in this direction with velocity v, okay, and it enters a magnetic field which is perpendicular direction. Transverse means magnetic field and v are perpendicular. Now we know that when the magnetic field and v are perpendicular, the motion of the charged particle becomes a circle, and whatever force acting on this charged particle basically is required to maintain the circular motion, that is the centripetal force. So that force will not accelerate in this direction, so that a force in this direction will remain unchanged. So what we can say is that the velocity in this direction will remain unchanged. So the kinetic energy will remain unchanged. Okay, so kinetic energy will remain constant, because as if you are moving it, the direction of force and the direction of motion are perpendicular. In other sense, you can say that the work done is 0. So you can write find this in terms of work done, you can find it in terms of basic logic, whatever you want. For physics terms, in terms of physics, you can say the work done is 0. So basically the kinetic energy will not change, kinetic energy will remain constant. You need remember the theory, right? So now let's move on to the question number 3. an electron is moving in a circular path under the influence of a transverse magnetic field. So, the similar question to the previous one, okay. And now in this case the magnetic field is given B is equal to pi times 10 to the power of minus 2 Tesla, okay. If the value of E by m is 2 times 10 to the power of 11 coulomb per kg, then the frequency of the revolution of the electron is. Now, frequency of revolution is given by omega by 2 pi, right. Now, if you remember in this case omega is given by 1 by 2 pi, omega is given by EB by m, right. So, EB by m, if you forget the expression for omega, you have to remember the expression for V. V is basically EB by mr, okay, and omega is nothing but V is given by QBr by m. If you remember, QBr by m was the expression for V, and V is equal to R omega. So, if you compare this equation from these two equations, you can see that omega is basically QB by m. Now, in this case E by m is given. E means the charge of the proton or whatever moving electron, okay. Here electron is given, so Q itself is E. So, that is why instead of writing QB, I have written EB by m, right. Now, from this expression let us put the values. E by m is given, so we can write B divided by not B, B multiplied by E by m. So, half value of B is pi times 10 to the power of minus 2, E by m is 2 times 10 to the power of 11. So, there is a 2 pi here, sorry, there was a 2 pi here. So, 1 by 2 pi. So, pi cancels, 2 cancels, and you can see this is 10 to the power of 9, 10 to the power of 9 hertz, okay, unit of frequency is hertz. So, 10 to the power of 9 means what? Kilo is 10 to the power of 3, mega is 10 to the power of 6, and giga is 10 to the power of 9. So, in this case 10 to the power of 9 means 1 gigahertz. That is the simple answer. Now, let us move on to the question number 4. When a charged particle moving with the velocity v is subjected to a magnetic field B, the force on it is 0. This implies that the angle between is either 0 or 180 degree, angle between is necessarily 90 degrees, angle between can have any value other than 90 degrees, angle between them can have any value other than 0 and 180 degrees. Now, we know that force is basically Q V cross B, okay. Magnitude wise we can write Q V B sin theta. Now, force 0 means Q is not 0, V is not 0, B is not 0, only thing that can be 0 is sin theta. So, sin theta is 0. Now, theta can be 0 or 180 degrees, right, both angles theta is 0. So, angle between is either 0, it is not in, is either 0 or 180 degrees. So, correct answer is option A, okay. Now, let us move on to the next question. A magnetic field of 0.4 K cap Tesla exerts a force of 2 I cap plus j cap times 10 to the power of minus 7 force on a particle having charge 1 microcoulomb while moving in xy plane. The velocity of the particle is. Now, this is a very tricky question, little higher level of the KCET. So, the difficult level of the KCET. Here you have to assume the velocity v is a I cap plus b j cap, okay. Since the magnetic field is k cap, so there should not be any k cap component in velocity v. So, you can see the answers also, there is no k cap component in the velocity v. So, you have to assume that velocity v is a I cap plus b j cap. Now, what you have to do, you have to use the formula, that Lorentz law. So, force is basically Q V cross B, okay. So, Q is 1 microcoulomb, microcoulomb means 10 to the power of minus 3, V is a I cap plus b j cap times cross product of 0.4 k cap. Now 0.4 is a scalar quantity. I can take it on our left hand side and I can write 0.4 times 10 to the power of minus 3. Okay, that is that does not matter. So what matters is the cross multiplication of these two terms. We know that I, j, k, when you are multiplying in this order, the third one is coming and it is positive. If you are multiplying in opposite order, then it is a negative term. So first is I cross k. So I cross k you cannot get in a forward order. So I cross k is the reverse order. So reverse order means it will be A minus j cap, right? A minus j cap. I hope you have understood this. Now plus B j cross k. J cross k means j cross k, that means it will be I cap, right? J cross k should give you I cap. I cross k should give you minus j cap. Okay, this is the simple form of cross product. Now we can write this as 4 times 10 to the power of minus 4, right? We can take this decimal and put it in the top. So it will be minus a j cap plus b I cap. Okay, now let me use the value of f given in the question. In the question, the value of f is given as 2 I cap plus j cap times 10 to the power of minus 7. That should be equals to this value. Now for simplicity, what I will do, I will take this 4 and multiply it inside and reorder it. So 4b I cap minus 4a j cap times 10 to the power of minus 4. Okay, so let me simplify this as well, minus 3. So it becomes minus 3, here it was minus 4, here it was minus 7. So I reduced it to minus 3. So now the expression becomes, this 10 to the power is now cancelled. So the expression becomes 10 to the power of minus 3. Now let me compare. Since this is a vector quantity, in terms of coordinate geometry, we can compare I cap component with I cap component and j cap component with j cap component, right? This is the trick. So 2 is equal to 4b or b is equal to 2 by 4 is equal to half. Okay. Similarly, 1 is equal to minus 4a. So a is equal to minus 1 by 4. Okay, so in terms of decimal, this will be 0.5 and a will be minus 0.25, right? 1 by 4 means 0.25. So you can see that what we have assumed, a I cap plus b j cap. So now we can write minus 0.25 I cap, right? A was 0.25 plus b is 0.5, right? So the correct answer is option C. If you have solved this question without taking any external help, then you are very close to cracking that 60 out of 60 KCET. Okay, so this is a difficult question, and if you have started answering this type of questions, then you are very close to cracking that CET 60 out of 60. So you have to practice a little bit more and then you can score 60 out of 60. And if you are not still able to solve this kind of problems, that means you are still not at that level. So you can judge your level by attempting this KCET mock test. So don't miss out on mock test. I say repeatedly, don't miss out on the mock test. Now, to send 10% of the main current through a moving coil galvanometer of resistance 99 ohm, the shunt is required too. So we know that Ig is equal to I times S divided by S plus G. These formulas should be in your fingertips, okay, so that you don't get stumbled on different values. So I by Ig is equal to S by S plus G. Now I by Ig by I is 10%. What is the meaning of 10%? 10% means 10 divided by 100. Right, 10% means 10 divided by 100. So 10 divided by 100 should be equals to S we do not know, galvanometer resistance is given 99 ohms. So simply you just need to cancel it. Now do the cross multiplication. So S plus 99 should be equals to 10S, or you take this S on the other side. So 10S minus S equals to 99, or 9S equals to 99, or S equals to 11. So S equals to 11 is the correct answer. So correct answer is option D in this case. Now you have to be very careful about these formulas and percentage and etc. This is also a simple question, but you need to practice this kind of questions. So a galvanometer of range 10 milliampere has a coil of resistance 1 ohm. To use it as a voltmeter of range 10 volt, the resistance that must be connected to the series with it. So very simple question. So the maximum current that can pass through the galvanometer is 10 milliampere, or 10 times 10 to the power of minus 3 amperes, right? And the resistance that we the voltage that we are trying to measure is 10 volts. So V equals to I G R plus G. So this is the external resistance that we are adding to the galvanometer, right? So V is 10 volts, Ig is 10 times 10 to the power of minus 3, R we don't know, galvanometer resistance is 1 ohm. So this 10 cancels, and some people have cancelled this and make a 0 here. If you cancel everything, there is no 0 because you are dividing it. So dividing means it is basically 1, you are not subtracting it. So this is also a bad habit if you are doing this. So R plus 1 is equal to 1 by 10 to the power of minus 3, that is 10 to the power of 3, that is 1000. Okay, so R is basically 1000 minus 1, that is 999. So 999 ohm is the resistance of the required resistance, right? Now this is also a similar question to that question number 6, but a little bit different. Here we are finding in terms of static values. In an ammeter, 20% of the main current is passing through the galvanometer. If the resistance of the galvanometer is G, then the shunt resistance in ohm is. So same concept. So Ig is equal to I S plus by S plus G. Okay. So 20% is flowing. So Ig by I should be 20 by 100. Okay, 20 by 100, that should be equals to S by S plus G. Okay, so here you can cancel that and you can cancel furthermore. So you will get 1 by 5. So now cross multiply S plus G is equal to 5S. Okay, so G equals to 5S minus S, that is 4S. So S is equals to G by 4. Right. So S is equals to G by 4 is the correct answer. A galvanometer coil has a resistance of 15 ohm and gives full scale deflection for a current of 4 milliampere. To convert it into an ammeter of range 6 ampere. Okay. So first of all, the maximum current that it can pass through the galvanometer is 4 ampere. Okay. Now you are trying to convert it into an ammeter, so that the maximum current it can measure is 6 ampere. So I is 6 ampere here. I is 6 ampere, but Ig is 4 milliampere. 4 times 10 to the power of minus 3 amperes. You have to solve this quickly. Okay, and they have given that G is 15 ohm. We know that Ig is equal to I times S divided by G plus S, right? So Ig is equal to I times S divided by G plus S. You just need to put the values. So Ig is given here is 4 times 10 to the power of minus 3 equals to I is given 6, S we don't know, and remember that to convert a galvanometer into ammeter, it has to be parallel only. So parallel and parallel are only options. Series we can simply strike off. Okay, series will not consider series at all. Okay, so only parallel is considered, and this formula is only valid for parallel combination. Right now, G is 15 plus S. Now here what we will do, we will use a smart trick. See, this value is very small. So when we are doing the cross multiplication, and the value generally is value of the shunt resistance itself is very small. So we will ignore one term in this multiplication. I think I have solved a similar problem while solving. So 6 times s is 6s equals to 15 times this. So 15 times 4 times 10 to the power of minus 3 plus 4 times 10 to the power of minus 3 times s. Now if you see on our left hand side we have 6s, and on our right hand side we have this very small 0.0004 s, right. So what we will do, we will ignore this term. We will ignore this term because this is, if I subtract this from 6s, it will not change much, okay, but our mathematics will be difficult. So only thing that we consider is this value. So 4 5s are 60, 6s equals to 60 times 10 to the power of minus 3. So s is basically 10 times 10 to the power of minus 3, or 10 to the power of minus 2 ohm, or it is basically 0.01 ohm. Okay. So none of the given answer is correct, right? None of the given answer is correct in this case. Now let's move on to the next question. But I think this is the correct answer. This should be the correct answer. They have done some misprinting. So this will be the correct answer. Now let's move on. The deflection in a moving coil galvanometer is reduced to half when it is shunted with a 40 ohm coil. The resistance of the galvanometer is, very simple question. Okay. So the galvanometer has a resistance G, and when you shunted it with a resistance of 40 ohm, okay, the deflection is half. Deflection half means the current in the galvanometer is half. Okay, the current in the galvanometer is halved, and you have added 40 ohm resistance. Now what happened? So initially suppose I current was passing. Now after you added this resistance, now the current is I by 2. That's why the deflection becomes half. Now where this other half I by 2 current is going? The other I by 2 current should be going through this 40 ohm. Now when do the current divide equally? In parallel combination, when do the current divide equally? Current divide equally only when the resistances are equal. You can solve it using the formula I equals to Ig G plus by S also, but not required here. You can simply say the current, since the current is dividing equally, so in that case the resistance of the galvanometer should be equal to that of the shunt resistance. If there the ratio was anything else, then you can use the formula that I gave you. Using that formula you can calculate it. Okay. Otherwise here you can use that Ig is equal to I S by G plus S nonetheless, but here because S current is already getting halved, you can simply use the logic and say that current is getting halved, that means the galvanometer should have equal resistance that of the shunt resistance, right. Now let's move on to the question number 11. A current loop in a magnetic field can be in equilibrium in two orientation. Both equilibrium states are unstable. Can be in equilibrium in two orientations, one stable while other is unstable. Experience a torque when whether the field is uniform or non-uniform. All orientations can be in equilibrium in one orientation. Now let us understand the magnetic force acting on a magnetic current carrying loop. So force acting on a current carrying loop is basically dependent on sin theta, angle sin theta. Okay, so we know that force on a current carrying loop is BIL sin theta, as I said. Now sin theta is has two values where it can be 0. Okay, one is 0, theta is 0. Another one is theta is 180 degree. Okay, so suppose I have a loop and there is a magnetic field. When they are in the same direction, okay, the current carrying loop, the direction of the current carrying loop, okay, and the magnetic field, they are in the same direction, okay, that is theta is 0. In this case, this is a stable equilibrium. Even if you rotate it by slight amount, it will again come back to its original position. But if you keep the current in the opposite direction, so that the magnetic field is now, the magnetic moment or dipole moment of this loop is in this direction, whereas the magnetic field in this direction. Now if you slightly rotate it, then what will happen? It will completely rotate and it will try to orient itself in the direction of magnetic field. Okay, because it will try to orient itself along the direction of magnetic field, this is not a stable equilibrium. Stable equilibrium means, I hope you remember stable unstable equilibrium. Okay, so there are few cases. Okay, this, when you put a ball here, this is called a neutral equilibrium. Even if you move it, it will move to the next position and it will stay silent at that position. So that is called neutral equilibrium. But if you keep the ball here and if you move it, it will come back to its original position. After a few rotations, it will stable at the bottom position. So that is a stable equilibrium. And if you keep the object here, at this position it is okay. So initially it is okay, it is an equilibrium because it is static. So any object which is static, no external force is acting on a system, then that system is called equilibrium. But when you move it by small amount, if that object don't come back to its initial position, then that is called unstable equilibrium. Okay, if you move it by small amount, it will continue to move without looking back. So that is called unstable equilibrium. Okay, so this is an unstable equilibrium. So the opposite one is an unstable equilibrium. This is unstable equilibrium. This is a stable equilibrium. Okay. Now a voltmeter has a range 0 to V with a series resistance capital R. With the series resistance of 2R, the range is 0 to V dash. Okay. The correct relationship between V and V dash is. Okay. So let us understand. The range is V, okay, and V equals to IR. Okay, V is IR. Now, in the second case, current in the galvanometer should remains the same. Okay, currents in the galvanometer should remains the same. Only V dash and 2R will change. So from this equation, we can see that don't need to write here. So 2IR. Now what we will do? We will replace this IR with V. So basically V dash is 2V. So V dash is basically 2V. We can see this is the correct relation. Okay, no need to worry about any other thing, anything else. Now a steel wire of length L has a magnetic moment M. It is then bent into a semicircular arc. The new magnetic moment is a very interesting question. So initially the length of the wire is L. Suppose the monopole at this point is M, monopole at this point is M. So initially the magnetic moment is small m times L, right? The any strength of any monopole times the distance between the poles. So that is the dipole moment. Now when you bend it to a semicircle, okay, that this length will remain the same, right? This length will still be L. Only thing that will change is the distance between the poles. Now the distance between the poles is, suppose the radius of the semicircle is R, then the distance between the pole is 2R, right? So distance between the pole is now 2R. Now what is the length of this wire L? Now what is the half perimeter of this circle? Half perimeter is 2 pi R divided by 2. 2 pi R is the perimeter of the full circle. So half perimeter will be 2 pi R, that is pi R. Okay, so R is basically L by pi. So we have calculated L. Now what is the new magnetic moment? New magnetic moment M dash is basically M times 2R, right? M times 2R. 2R is basically L by 2 pi. So it will be 2mL by pi. Now what is ml? ml is nothing but capital M. So 2m by pi. So new magnetic moment is 2m by pi. So this is the correct answer. Now let's move on. Question number 14. The absence of magnetic monopole is explained by Gauss's law. I told you multiple times while teaching this concept, the absence of magnetic monopole is explained by Gauss's law. A circular coil of diameter 2 meter, 100 turns, carries a current 1 ampere. What is the magnetic moment of the coil? So circular coil of diameter 2 meter. So diameter 2 meter means what is the radius? Radius is 2 divided by 2, that is 1 meter. Okay, and 100 turns carries a current 1 ampere. What is the magnetic moment of the coil? Magnetic moment of a coil is given by NIA. Okay, National Investigative Agency. So N is given here, only one circular coil, right? One coil is given, so N is 1. I is given here as 100 turns is given, sorry, my mistake. So 100 turns, N is 100. Okay, I is given as 1 ampere and area is pi r square. So pi r square, r is basically 1 meter. So 1 whole square. So it will be 100 pi, current is 1, so 100 pi. So 100 pi is nothing but pi times 10 to the power of 2. So pi times 10 to the power 2 ampere meter square is the correct answer. Now a magnetic needle lying parallel to a magnetic field requires W unit of work to turn it through 60 degree. The torque required to maintain the needle. Okay, now we know that when there is a magnetic field, okay, and magnetic needle, suppose the magnetic needle has a magnetic moment M and there is a magnetic field is B, then work done is basically given by MB, M dot B, that is MB cos theta, and the torque at some angle is MB, M cross B, that is MB sin theta. Okay, so torque is MB sin theta, work done is MB cos theta. Now how much torque is required, that they have asked you. So what we will do from this equation, we will find the value of MB. So MB is basically W by cos theta, right? So put that value here. So W by cos theta times sin theta. Okay, so the torque required will be MB tan theta, sorry, W tan theta. I sometimes making mistakes today. Tan theta. So W is basically W, tan theta 60 degrees, tan 60 is root 3. So root 3 W is the torque required to hold it in its position. Very simple, interesting question. A bar magnet is oscillating in the constant magnetic field with a period T. If the mass is quadrupled, then the time period will be. So time period of oscillation, I told you 2 pi root over of I by MB. Here don't confuse this M with mass. This M is magnetic moment, magnetic dipole moment, B is magnetic field, I is moment of inertia. So mass is hidden inside moment of inertia. I is basically half M R square, right? For when it is rotating or moving along the center of mass, and the distance of the center of mass is R square. So basically we can see that time period is basically proportional to the square root of the mass, right? So because I is dependent on mass, so T is proportional to mass. So T1 by T2 is equal to square root of M1 by M2. Okay. Now T1 is given T, T2 say T2 only, M suppose say M, and it is quadruple. Quadruple means 4 times. So it will be 1 by 4. So square root of 1 by 4 is half. So T2 will be 2T. Okay, this will cross multiply. Okay, so T times 1, T2 times 1, T times 2. So T2 is 2T. So 2T is the answer. Now next question. A magnet makes 40 oscillations per minute at a place having magnetic field strength of 1 times 10 to the power of minus 5 Tesla. At another place, it takes 2.5 seconds to complete one oscillation. The value of magnetic field strength at that place is. So now first it said that 40 oscillations per minute. 40 oscillations means 40 oscillations in 1 minute means 60 seconds. Okay. So how much time it takes to complete one oscillation, that is the time period. Okay, one oscillation time is the time period. So let us find the time period in the first case. So it is divided by 40, 3 by 2, that is 1.5 second. That is the time period, first time period. T1 is 1.5 second. Now next they said the time period after at a different place, time period is 2.5 seconds. Now this case time period itself is given. Now we know that time period is 2 pi square root of I by mb. So time period is basically proportional to 1 by square root of b, right? So time period is proportional to square root of b. Now T1 by T2 therefore will be square root of B2 by B1, inversely proportional. So first it will reverse. Now T1 is given by 1.5 second, T2 is given by 2.5 seconds, B2 we don't know, B1 is given 1 times 10 to the power of minus 5. Okay, so let solve this. 3 5s are 15, 5 5s are 25. Now square both side. So 9 by 25 is equal to B2 divided by 1 times 10 to the power of minus 5. So let me clear up some space here. So B2 is basically 9 by 25 times 10 to the power of minus 5. Okay. Now 9 by 25 is what? How can you find what is 9 by 25? So because all the decimals are given in decimal number, so easiest way is to 25. How can you make 25 into 100? Okay, to make 25 into 100, you have to multiply it with the 4. Okay, so multiply it with the 4. So top and bottom. So if you are doing it in this is a fraction. So if you are multiplying with the 4, you have to multiply in the numerator as well. Now 25 by 4 is 100. 4 times 9 is 36 times 10 to the power of minus 5. So basically it is nothing but you can see this is 0.36, right? So if you are confusing how you can manage these things, you have to practice and more practice. So 0.36 to the power minus 5. So this is the correct answer. Now in normal iron piece there are no magnetic dipoles. Magnetic dipoles are arranged in a specific direction. Magnetic dipoles are arranged in random direction, none of the above. So iron is a ferromagnetic substance and it can be converted into magnet, but in normal iron piece basically magnetic dipoles are arranged in random direction, magnetic domains are arranged in random direction, so that the net magnetic moment of that iron is 0. So correct option is option C. Relative permeability of a ferromagnetic substance is 1100. Okay, its magnetic susceptibility is. So what this is given? Relative permeability. Relative permeability is given, and we know that that is nothing but 1 by chi, and they have asked you to find what is chi. Okay, so relative permeability is 1100 sorry, is equal to 1 plus chi. So chi is nothing but 1100 minus 1, that is 1009. Sorry, 1099. So 1099 is the correct answer. The relative permeability is presented by mu r and the susceptibility by chi for a magnetic substance. Then for a paramagnetic substance it is. Now you should remember that for paramagnetic substance mu r and chi both are positive, and they are not very highly positive, but they are positive, and mu r is greater than 1. Okay, so mu r is greater than 1 and chi is positive. So this is the correct option. Only for diamagnetic substance chi is negative, and for diamagnetic substance chi is less than 1, but it is greater than 0. Mu r cannot be 0. Okay, so this is the case. Now question number 22, when a material is placed in a magnetic field B a magnetic moment proportional to B but in a direction opposite to B is induced. The material is, obviously when you place a material in a magnetic field, if it is a paramagnetic, there will be a small induced magnetism in that, but in the direction of it, and if it is opposite to that, only one possibility is a diamagnet. In case of a diamagnet, the induced magnetism is opposite to that of the magnetic field, right. Among the following properties describing the diamagnetism, identify the property that is wrongly stated. A diamagnetic material do not have permanent magnetic moment, obviously correct. The diamagnetic magnetism is explained in terms of electromagnetic induction, can be done. Diamagnetic materials have a small positive susceptibility, which is not correct. So, this should be our answer. The magnetic moment of individual electrons in neutralize each other, that is also correct for diamagnetism. Okay, so only thing is the diamagnetic materials have a small positive susceptibility. So, this is a correct option. Above Curie temperature, a paramagnetic substance becomes ferromagnetic. Okay, a ferromagnetic substance becomes paramagnetic, diamagnetic substance become paramagnetic, paramagnetic material becomes diamagnetic. Though even though this question is not directly related in your syllabus, but still this question is may come. Okay, they might say above certain temperature a diamagnet can become a paramagnet can become a ferromagnet, or ferromagnet can become a paramagnet. Okay, so ferromagnetic substance becomes paramagnetic. This is the correct. Above that temperature, ferro becomes para. Below that temperature, para becomes ferro. Okay. Now, needles N1, N2 and N3 are made up of ferromagnetic, a paramagnetic and a diamagnetic substance respectively. A magnet when brought close to them, okay, so which one is ferromagnetic? That is important. N1 is ferromagnetic, okay, N2 is para and N3 is dia. So, N1 will be strongly attracted, okay. So, attracted N1 strongly, N2 weakly. Okay, N2 is a paramagnetic, so it will be attracted weakly, and it will be repel N3 weakly. So, because it is a diamagnet, so it will be repelled weakly. So, correct answer is option B. Okay, N2 will not be repelled, it is a paramagnet, so it will be attracted weakly. Now, let us move on. A paramagnetic substance of susceptibility 3 times 10 to the power of minus 4 is placed in a magnetic field intensity of 4 times 10 to the power of minus 4 ampere per meter. Then the intensity of the magnetism is. So, what is given? Susceptibility is given. Okay, magnetic field intensity, that is H, is given. Okay, and they have asked you to find the intensity of the magnetism. M is equal to chi H. Simple as that. Okay, as simple as that. So, 3 times 10 to the power of minus 4 times 4 times 10 to the power of minus 4. So, 12 times 10 to the power of minus 8. So, 12 times 10 to the power of minus 8 is the answer. The relative permeability of a medium is 0.92. What is the magnetic susceptibility? So, again the same formula, mu r is equals to 1 plus chi. Okay, so, chi is basically mu r minus 1, mu r is given 0.92 minus 1, so it will be 0.08. So, basically it is a diamagnetic substance. It is a diamagnetic substance because the answer is coming out to be negative, right. 28, I told you this formula, it is T 2 pi I by mb. So, this formula I have solved multiple times. The magnetic susceptibility of a material of rod is 499. The permeability of vacuum is 4 times 10 to the power of minus 7 Henry per meter. Absolute permeability of the material of the rod in Henry per meter is. So, what is given? So, magnetic susceptibility is given. So, chi is given. So, chi is given 499. Okay, so, mu r, we know that mu r is 1 plus chi, that is 1 plus 499, that is 500. Okay, now what is absolute permeability? Absolute permeability is mu r, mu naught. So, mu r we have calculated 500 and mu naught is given 4 pi times 10 to the power of minus 7. So, it is 5 times 4, 2000, pi times 10 to the power of minus 7. So 2000 means we can reduce 3 zeros. So 2 pi times 10 to the power of 3 zeros means minus 4. We reduced 3 zeros, so it will be minus 4. So 2 pi times 10 to the power of minus 4 is the correct answer. A magnetic field intensity of 3 times 10 to the power of 3 ampere per meter produces a magnetic field of 12 pi Tesla in an iron rod. The relative permeability of the rod is. So what is the magnetic field intensity? Magnetic field intensity, that is H, is given by 3 times 10 to the power of 3. Produces a magnetic field. Magnetic field is given. Okay. Magnetic field is given as 12 pi. Okay. So what we know that mu is equals to or let me start with the basics. H is equals to B by mu. Now mu is basically mu r mu naught. Okay. So they have asked you to find mu r. So mu r will be B by mu naught H, right? You take this down, take this up, just exchange, student exchange program. So mu r we are trying to find, B is 12 pi, okay, mu naught is 4 pi times 10 to the power of minus 7, we already know that. H is 3 times 10 to the power of 3, okay. So 3 4s are 12, 12 pi, okay. So here also 12 pi times 10 to the power of minus 7 plus 3, so minus 4. So 12 pi cancels, so 10 to the power of 4. Okay, so mu r is 10 to the power of 4. Correct answer is option A. So we have completed today's KPL question paper 4, and if you have not yet subscribed to our channel, don't forget to subscribe to our channel, and don't forget to download the question paper from our website every Sunday, and then in the evening I will be coming back as usual with the solution for this question paper. Next week question paper, I will see you next week with another match, that is match number 5. So we have already played 4 matches, and tell me how many matches you have won. Okay, so I will be back tomorrow with a new lecture. So till then, tata, bye bye, see you.